Okay, I think everyone can hear me now, hopefully, getting the audio set up there. Sorry, it's a one-man show, and that proves to be a little more complicated, I've learned. Um, it's a lot easier just to set a camera and go. It's a little more hard when you're trying to change between using a camera to actually see people and have some social interaction while we social distance, but also share my screen, and do the audio and all that stuff. Anyway, here we go for day 3. This is probably going to be, in my opinion, the most useful video and probably the most interesting one. I'm going to cover a lot of differences between C and C++, some obvious, some not so obvious. And these are things that I have come across myself. A lot of this is learnings that I have done through making mistakes. So I'll probably make a few mistakes today like I did, every other day. That's just part of the process. But this is going to be probably, like, content-wise, the most interesting. So let's get started. So let me get over here to my desktop. In case this is your first video, hopefully you've checked out the other two, but in case not, I have all the software that I'm writing, and I'm pushing it live during the session to GitHub. So this one here, this is the project, 08malooz/software sessions, C-CPP. Conceivably, I might do more software sessions in the future, depending on what the interest is. And I pushed a new project up here called C versus CPP. Pushed that up there about half an hour ago as I was getting ready for it today. If you're also looking for, like, where to find all this stuff, or I know more about me or anything fun like that, 08malooz.com is the place to go. There is a blog post that has some helpful, links on there, as well as links to a way to contact me. I'm watching the comments as much as I can, and stuff like that. But, if I don't catch it in a few weeks and you're watching this, that's a great place to leave me a note. It also has the links to GitHub, and the links to all the other videos. So great place to go. Just plug in that in case you aren't aware. And that, again, is just 08malooz.com. So you can go there. And right now it's all the current stuff, but I have it all tagged under the keyword software sessions. So if you want to dig it out here, or you can use the search functionality. But every post is tagged with software sessions, so it should be easy to find. You can find them all in here. I've also grouped all these videos as a playlist on YouTube, so you can check that out too. So there we go. That's all the logistic stuff. Let's get into some software discussions. So I pushed up a project, C versus C++. I did the same thing we did in video 1, where I removed the precompiled headers for this, and then I actually added a few files. And we have sort of two sets of files here. We have a C file and a CPP file for both headers and actual code files. The idea here is that we're going to be talking about the differences between C and C++. So we're going to try and do things in both, and see how some things are similar and how some things are different. And then we'll call them from this main function just so we can sort of play with that. So we'll start off on the C side using some of that logic that we talked about yesterday. And one thing I forgot to mention, which would be static declarations. So here's my CPP file. It includes both my c.h and my c.cpp. It's great. In the C file that I'm going to include here, let's have a function that returns an integer called my function. And my function doesn't do much other than it increments a global. So I'll put a global in here. I'll make it a global array because we didn't talk about static declarations of arrays. So we'll say int and there we go. And we'll give it a size of like 5. And it will go through here and it'll say a 0 plus plus a sub 1 plus plus a sub 2 or 2 plus plus. We'll, just to be ornery, we'll do a sub 3 minus minus, just to change things up here, and a sub 4, right, minus minus. Pretty simple function. If you recall, I have to declare this in the header file like we talked about yesterday, so I'm going to go to c.h, and I'll just put that up there in the header file. And then I'm going to make this function return, I don't know, a sub 0, just to be something that we return. Save the header file, go to my CPP file, call my function, and put printf. Here is the return from my C function. There we go. My function. So that's one of the things, by the way, that you can do. We didn't talk about this explicitly, but you can actually call functions and stuff inside of printf, because I'll return an integer. So as far as printf is concerned, that's a valid thing to do. Let me set this over to x64. Shouldn't change really anything, and we'll build. Let's hope I didn't. Oh, there were some build errors. What did I do? One unresolved external symbol. Ah, I didn't include in here. There we go. I got to include the header file to link everything, so it struggled. Nope, still have some build errors. Into my function. There we go. We're including c.h. There's my function. It's doing its thing. Well, there we go. Knew I wouldn't be long before I mess up. Let's figure out what I did wrong here. I'll rebuild this. This one's got me. Because I have the header files linking. They're all added together. C.h has the int my function. It's called here, which is what it should do. And it's included there, which makes sense. Doesn't give me any warnings on here saying I need to implement the function. I bet you that it's trying to execute this as C. So maybe I need let it know we're going to execute this as C. I want to say that's the right way to do it. If I'm not mistaken. Yeah. Let's try that now. Yep, it's exactly what we need. So, and it ran. So that takes us to our first bug. And it's one that I have caught. It's one of those things I don't think about very often because I don't mix this very often. But extern C is a thing. So when you mix C and C+ code, you need to let the compiler know how to interpret something. So it sees this .c file as C code, because I named it as that, and it wants to treat it as such. So in our main file here, we need to declare that as an extern C, basically telling the compiler treat it as C and not as C++ code. This one has caught me on more than one occasion, and you just saw it do it to me live here. And basically, we can use that extern keyword. If you recall, we used that yesterday for a function. In this case, we use the extern keyword to indicate that we want the code to be read as C. So that's what that was doing there. So that is the first plus. Where that comes really into issue is like using other keywords and making sure they're supported correctly. If you notice here, I did do a static declaration of an integer. So int5 is statically allocated memory. I didn't need a malloc function there or anything like that. I was just able to, say, I have 5 integers, and I was able to access them with no issues whatsoever. So My function's not terribly exciting, but there it is. Now, if we want to do this in C++, we can do it. There's a couple of ways we could do it. We could implement it as just C code inside a C++ function. That is probably the easiest, but probably not the most useful way to do it in terms of long-term code maintenance. We really should add this to the C++ class to keep things explicit and clear, because as you can see, when things aren't explicit and clear, we run into issues. So I've actually gone ahead and created a small C++ class. Again, this is all up on GitHub, so you can pull down this. I've seen a few people have joined the stream since I first said that, so I recommend you pull this down because it'll at least get it started for you. Anyway, as my girlfriend closes my bedroom door behind me. In the C++ file, we actually implement the class. If you notice, the class has this concept of a namespace, so that helps you logically group different classes or functionality. So you might have a namespace that is, in this case, the namespace is C++ class. I might have another namespace that is adder, that implements everything that would be inside, maybe a logical adder. I might have another namespace that does something that is logical shift and does everything there. You can sort of section it off, and then any class inside this namespace can interrelate and sort of use all those terms. So once you've declared a class inside the namespace, you can then if using the keyword using namespace, you have access to everything in there. So we can pick up my class, and then we can, this is actually how we declare the function. So we give it the class and then the function. Quick crash course in object-oriented programming. You have a class would be like an object. So if we think of an object being a car, for example, you can have different properties of those objects. So you might be talking, if you have a car, you're talking like, it's the color blue. It has 16-inch tires. It's actually a truck, maybe, those sorts of things. It has windows, and then you can have methods. It can do things. So the car can drive forward. The car can turn left or can turn right. The car can go into reverse. And those are actions that would be taken. And sometimes those actions are specific to it being a car. Sometimes those actions are just things that, and you need to actually have a car to do it. Sometimes you can have actions that don't require anything specific to the car. So say one aspect of a car is, I don't know, sharing a picture of your favorite car, right? You don't actually need to have, like, I love Corvettes. I don't need to have a Corvette to share a picture of a Corvette. I can have a picture of a Corvette. It doesn't drive forward. It doesn't drive backwards. It doesn't turn, but it still looks like a Corvette. So you can have those sorts of functions, and we call those static functions. So in the scope of what we're doing here, to sort of mirror what we did in the C code, we would just create a static function in here. So this would be, you declare it static, my function, CPP, and it does the same thing. It's going to yell at me saying, oh, needs its type, int, still need that. It's going to yell at me saying I need to implement it now, and I'll do that here in a second. One of the other advantages of how classes are structured is that we can actually have things that are accessible and things that aren't accessible. So remember we had that global variable in the C file here, and it's only accessible from inside this particular C file. You can only see it from inside this file. Sometimes your class might be implemented among 3 or 4 different files, and you want to have the same, global to that class, available. You can still do global to the file, so I could declare it. If I want to copy and paste A here into the CPP file, it would be global to the file, just like in C. That's no problem. But what if I implemented this class over multiple files, or I needed to, for some reason, add on to it later or something? I can group it inside the class as one of those fields, like the color of the car. And I can also make it private so that no one outside of my class can access it. Because when you create like an instance of a class, you create the object, other people can action on it. So if you create a car, of course people can open and close the door, but maybe you can't. Grouping here, and I'm going to put my global values of A here as well. Again, statically declared, don't need to worry about malloc, and actually we don't use malloc in C++. I'll get to that in a little bit. But yeah, we put that there. I'm going to cheat. I'm going to let it create the definition for me in the C++ file. It already does that, because that's one of the nice perks of Visual Studio that I really love. So here it goes. It created that, and I can say, in this case, a sub 0 equals 10, and then I'll just return a sub 0. You know, particularly, special here. Oh, so there is a gotcha. Again, like I said, they're going to be coming to me all throughout the day. Unlike the global that we can reference any time in here, a static member of a class can't actually operate on the class. So if we wanted to, action on A, it can't be a static member. It has to be a regular member of the class. So in this case, we'll just say my function returns 10. It's a not terribly exciting one. But if we want to make it so we can actually operate on A, we'll make a non-static version of this. I'll just rename this one static. There we go. And then my non-static one, I will let it implement for me, again, because I love that feature. And I can put in a sub 0 equals 10, and then I can return a sub 0. There we go. Now to use these functions, things get a little bit more complicated. So in our header file here, I was just able to call my function. We can do the same thing with the static function, actually. So I can go over here, but I need to give it some more information. So I first need to tell it what namespace I'm using. So using namespace, and then this one here was CPP. I need to double check what my namespace was. It is CPP class. There we go. So I have to first tell the file, hey, there's this namespace out here. And then when I want to call my function, the static one, I need to call my class dot, and then I call my function. And actually, I believe I need a new instance of it to do that. There we go. That would create a new instance of my class. I'm not actually sure I need a full-on constructed instance of my class. I think I should be able to do and reference it that way. Yeah, there we go. So I don't actually need to construct it, and we'll get to what that is here in a second. But this should run and build. Like I said, we're going to hit a whole bunch of little bumps because there's a lot of idiosyncrasies I'm going to talk about. And there we go. It returns 10. It ran. Life is grand. So I'll close that out. Cool. Now if we wanted to use our other function in here that says, we'll say this one's equal to 9. My C++ static class function. Now let's do the same thing with it just as a regular class. So to do that, I need to have an object created. And to do that, we can create it several different ways. The first way is we can call my class A, and that will create it. And I can do a.myfunction.cpp. That's one way. That works. I can also do a pointer to a class. So my class, remember we talked about pointers yesterday, star aptr equals new my class. Yeah. And this will create a new instance using what's called a constructor, and we'll go over that here in a second. And then I can do the same thing down here. So if I go to run this, you'll see that it worked and returned 9 both times, 9 being the value from our non-static version of the class. Now I talked about a couple different ways to do it. This first way basically calls the constructor for you. It's very clean, very much my preferred way to do it. But sometimes having that pointer is helpful. Remember we talked about yesterday that pointer to a memory location is a big, sort of asset in terms of passing things around and doing that sort of thing. So creating it and having a pointer to it, or you could even cheat and you could say, my class A, and then APTR, points to the address of A. You can construct it lots of different ways, but I prefer creating the pointer and doing it this way if I know I'm going to be passing it around later. To do that, though, you have to use this keyword here called new. So just remember how we had to use malloc yesterday to allocate memory. In C++, we use the keyword new to allocate memory, which makes life a lot easier because the opposite of new is delete. I don't have to give it a size. I just say new integer, and give the integer size. I don't have to calculate it out saying, 5 times the size of an integer, sort of thing. I can just sort of do that. So that's how that works. Now, I said that constructor. So if you notice, I have a couple of functions here that are defined. They're currently empty. My class and then tilde my class. My class is the function my class is the constructor. Basically means it assembles everything. And then the destructor means when you get rid of the object is tilde my class. The destructor should be automatically called when you go to get rid of the object. So if I was to call delete on a pointer down here, it would call the destructor and then clean it up, that sort of thing, basically when it goes out of scope. That also means, though, that we can actually operate on things here. So maybe I say, in this case, that a plus equals 9. And maybe on my constructor, I say a sub 0 equals 400. So what's going to happen is when we create this my class object, it is going to run that code, and it's going to set a sub 0 to 400. And then when we call our function, it's going to return it as 409. That's what we would expect. So here we go. Let's run it. Cool. We see 409. Oh, and we see it's now 418 the second time it was called. So, that's me being dumb. Like I said, there's lots of little gotchas in this. I was pointing to the wrong object. And one other thing is when you're using a pointer, you don't use a dot to dereference something. You use the arrow, and that basically converts it from being a direct function call to dereferencing the pointer and then calling the function. So here if we go again, there you go, it's 409. And if I reran, say the second one here a few times, you'll see that it does increment it multiple times. It does add 418, 427 as we saw in the previous one. And that's because it's just incrementing that global. Now I can't get this global value anyway. There's no good way in this header file to access it. So I need to set up some way to read out this value. And this is one of those cases where sometimes it's easier to just declare the function in the header file. So I'll say here int get a, and it returns, maybe it's a, get a 0, and it returns in here as well. It's just standard C code, that sort of thing. So if I want to go back to my main program here, I can say the starting go. And I can do that down here too. I'll just copy that line and tweak it. There we go. And if I run this now, we'll see that it shows the value of A0, and it gets it. This concept of a getter, you can also have what's called a setter, is to set a value, helps add security to your programs. Conceivably, this could be a issue where if you have someone else writing in some code or something like that, that they could access or set something or mess something up completely. So sometimes you want to say, hey, the color of the car is blue, but please don't paint my car. You can't set the car's color to anything other than blue, so you just put a getter on it. So internally, the manufacturer, can privately set the car value to blue, but then you have your, way to make it, that the user can't repaint your car, going back to the car analogy. Also, you might say, I want to set something, but not let the user ever get it or see it for some reason. You can do that as well. And you can make a, public setter, but no getter, or a private get. So these are something that's pretty common in most object-oriented programming languages. And it's something you can easily do, like I said, here in C and C++. So we'll dive back into this here. Curious if there's any questions out there. So I'll throw a question out there in the chat, see if anyone's listening. But yeah, there's lots of little details and stuff. So I'm going to try and keep this going. I do see that on my live stream it looks a little blurry. I don't know if that is me or not, but if it is blurry, let me know in the comments, and I'll see if I can bump up the font size or something like that to cope with it. It looks fine on my streamer, but my YouTube monitor says otherwise. So feel free to let me know that. I'm watching the comments as well. So cool. So those are a lot of the idiosyncrasies between the two. We might need to pass some data between each of these as well. So, if I want to send data from this particular function, from my main function over to, say, a different value in here. So we'll say so you pass an integer. We'll call this send data. And maybe this changes. It'll actually give me the ability to create it in there as well. Again, I love that feature of Visual Studio. Go over to my C code, and maybe I'll return value just to be ornery, and then I will set, ace of, 4 plus equals value. Why not? And then I'll return ace of 4. That'll be more useful. Right, so I can send data as well between C and C++. So this would be a C++ function because we have classes and stuff, and it's a .cpp. But if I want to come up here and send data between them, I can I can call, I believe this was send data. There we go. And I'll send a value of 100. Sure. There we go. And if I go and I run this, see here in the debugger, we'll see that, there we go. We sent data between things and we got 99. So we can easily send values to and from C and C++ functions from each other, which is really handy. So we sent it, 100 and it returned. We can also send memory between them too, just the same way. So that's really cool. I'm gonna create a little bit of space here just to make life a little easier when we go to read it. Just There we go. So now when we go to look at our debug, oh, I had build errors because I didn't put my semicolons on the end. There we go. It just spaces things out here a little easier. So cool. So we've gotten into a bit of this. I said memory allocation is a little different in C++. So let's allocate some memory. Let's say we have in our header file just a generic array in star. We can still use pointers in C++. We'll call this B because I'm very original. One of the things that I need to do now is I need to allocate B. So I'll say B equals new int array, and maybe 100 or 1,000. Sure. There we go. I've allocated this int array of B. Life is all happy. Now, one issue, remember we talked about when we talked about memory and pointers yesterday, you do want to make sure that you clean up after yourself because things can get really messy. If I create some memory in the constructor, I probably want to remove it in the destructor. Now, here I want to call delete B. Now, if you're a veteran C++ person, you're probably screaming at the screen right now, oh my gosh, you forgot something. And I did. There's actually two forms of delete in C++, just to make things more complicated. If you allocate something as an array, you want to use the delete with the array brackets. If you allocate something as just a block of memory, you'll want to use the delete command. So if I was going to create a new class in here, or I was going to do something like that, I'd use the regular delete and then the pointer. But if I'm creating something as an array, it's proper to use the delete brackets. But now I can operate on B because B is created when this class is constructed. So I can also go in here and say B of 542 equals 17. And I can also have a get or a getter for B as well. So copy my getter for A, and I'll say get B, get B 542. There we go. And I'll call it down here. And since I'll just use the APTR one. There we go. And then we'll call the new value of B542. We would expect these to be different. So let's see if that holds true. And it starts value of 17, has a new value of 17. What went on there? Let's find out. I bet you I know what went on. So the issue is we've already operated. We've actually already called that function a few times. So in this case, I'm going to do a delete to clean it up. And then I'll reallocate a pointer and make it equal to a new one. So this is showing that new and delete again over here. Here we go. Now it's saying the value of B is negative a whole bunch. It looks like just a space in memory. Ah, I found my next blunder. And this is a lot of writing software. It's rarely right the first time. Debugging is definitely part of it. Here we go. There we go. And the value is 17. Now, there are some helpful C and C++ functions to deal with these arrays, because being this garbage number just means it allocated a whole bunch of memory but didn't do anything with it. So One thing we can also do in this case is we can do a command called memset. And memset will actually iterate over an array and set values. You can also use 0. Maybe. I think you need to include, I think it's standard IO. I might be mistaken. Yep. You'll find out. What is the memset? It is in standard die. Allows them all to 100. Let's be, ornery, right? And then it tells me how many I want to do. So we know that A has a size of 5. So I put that in there. We can do the same thing with B. I'll use 0. 0 isn't in there, but I have to go hunting which library 0 exists in. And we'll set them all to 4. Why not? And then we'll set in 1,000. Now, one thing that is common among C and C++ that we haven't talked about yet that can get you into trouble with things or help you get out of trouble is using the preprocessor. The preprocessor runs before the compiler does to actually process some of this data. So in this case, I'm dependent on the size in 2 instances. I maybe want to keep that size around. So I might go over here in my header file and do what's called pound define. I'll name it bsize and set that to be 1,000. So now I can use bsize here and bsize here, and that'll be good. And I can say also in my getter function, if I'm really worried about this, I can say if 542 is greater or is less than bsize, right? Return that value. Else, we can be clean and return 0. Probably means that something didn't go correctly, and we can do that. And I'll, clean it up. There we go, bsize. So we can reuse it all over the place. So if I go to run this now, we build. It appears memset did not run. That is strange. Run, and every value of B, That's curious. Like I said, you guys are seeing this live with me, so sometimes you get these weird things going on where functions aren't performing exactly as you'd expect them to. I'll pass it the address to both of these. What I probably did was was off in pointers. Well, that's a new one why memset isn't running. Memset should take a pointer to something, which it is, and then going from there, but I guess it's not. What we can do instead is we could also just write a while loop, which is essentially what memset's doing. And then we can say b sub I equals 4. That much I know will run. So now if we go to run our code, there we go. We see it initializes the value to 4, and then it sets it to 17. Yeah, there are some handy functions like memset, like 0, and a few others. I'm not quite sure why they didn't work as I expected on here, but that's definitely something we can check out later and dig into at another time, or if you have questions. I do have a question up here. My question is, Nightbot is asking about 2D arrays. So you can declare a 2D array, What does M and N mean, and are they row or columns? So row major and column major are actually dependent on the architecture. Conceptually, it shouldn't matter for a lot of your functions, but there are mathematical functions where you're setting up an array or a matrix like that, and you're trying to do plus is row major. But I can quickly double check that. So yeah, row major is C and C++. That's not always true on different architectures as well as different computers. For instance, Fortran is column major. So some GPU computing, you might need to change that. But yeah, so in this case, what you have for your example that you sent, M and N, M would be the column, M would be the row, and N would be the column. So hopefully that helps you there, Nightbot. So like I said, we can zero out the array and we can access on it. And all this is running in this constructor before. You're going to want to keep your constructors simple and lightweight so that they run quickly. And you also often don't want to do lots of logic in them. Save that for the functions of your object. You want to keep them small, set up memory, initialize values, that sort of thing. And yeah. And like I said before, this concept of a B size of being 1,000, you can use the pound define and use that anywhere. The other way we could also do, and there is this constant that I can now use, in case here I want to do array size info, which is not the best name, but it's what came to mind. One uses the precompiler. One is something that you can debug and actually. So if this is, if you're trying to decide if you want to use this, and this is useful in both C and C++, the constant is great if you're going to use it at some point. The macro, like your program might check it or something like that, and actively use it. During execution, dynamically coming upon it or something like that, as where the pound define is a little nicer if you just want that value pasted in. It makes your code a little bit smaller because instead of having to check a memory location with that value, which could be perceived as slower, what it does is it checks, or actually just pastes in that number when it compiles and goes from there. Those are minor performance advantages. Probably not something that most applications will need to worry about. It is nicer, in my opinion, to have it as a constant there if you can. And generally speaking, your compiler will see that it is something that doesn't need to be accessed. cpp.h. What is this looking like on the C side? I'm getting a spinning wheel up here. Hopefully that means, it says excellent conditions. Hopefully that means the stream is still pretty good. We will find out. I'll watch it later and see and make sure that all that's going through fine. It says my uploads, but how we use header files and how we use the C file becomes a little more interesting. So if I want a private global, I declare it inside the C function here. If I want it to be a public global, I can declare it, extern like we did yesterday inside the header file. So I'll say so here's my externent public global, and I'll declare it inside of my C file as well. And maybe I say it equals 5. Well, %d. And then maybe I set up a C function here. And subtracts 1,000 off of it. So I'll call my function. Not terribly interesting. My semicolon, like I do so often there. I ran my function again, and it set it down. It subtracted 1,000 off. So you have this like a public variable in your function. If you want to make a private function, so I could make a private function in here too, and just declare it inside the C file. Maybe I call this void loop or void add to global. And this does public global. Maybe it adds 500. So then I can call here add to global. But I cannot call add to global from this function. If I go down here and call add, notice add to global doesn't come up. And if I even put it in here, I'm going to get a build error saying it has no idea what add to global is. See, it doesn't know what add to global is. But we just did add to global right here. And that's because it's declared. So this would be like a private function trying to compare C to C++. If you're creating an object and that sort of thing. So that's one of the ways that you can action on things. Now, what's really cool and interesting is you can do the same thing in C++ too. I can declare a completely separate function in here. I could declare a function that is, right, add to global, and I can say add to global right here would just add, or maybe this returns a value int, and we'll call it add to something, and it takes in a value, right? Declare that. I can do this down here. And I can do value, or value plus equals 1024. Why not? And we can return value. And yeah, you could combine that into one line if you really wanted to. But this is not accessible now. This add to something method is also not accessible here. Right? We don't see it. Doesn't come up in our IntelliSense. But I could call it from a function. So maybe I want to say b equals add to something of 17. And I can actually run this now, and it has no problem calling. So you can mix and match sort of like that. Again, that's sort of private to a file. It's not considered the best style, in my opinion, because you're sort of now mixing C concepts with C++ concepts. It is doable, but maybe not the best way to go. If I was writing this for a larger application and not just demo purposes, I would make this a private function, which I can easily do, actually. So if I want to promote this to being a private function, which would be the best way to do it in C++, I'll just go and I'll just add it up here. And then it's probably going to say, oh, I need to implement it down here. Well, that's easy to do. I just need to put this big... Actually, I don't even need all of that. I don't need the namespace out in front. I can make it simpler. And do that. And it runs. And it does the exact same thing. It's just grouped in the class now. And that's a little bit better just from a style standpoint. Typically, when you start debugging code and you start going through things, the header file is where you start to sort of say, do I need to go into this file and figure out, something or debug it? you start in the, you look at the code line that goes wrong, and then you start looking at like the header file of what's calling it and all that. And if you're, accessing a function that isn't, seen or is actioning on something that you're not aware of, it's can make life a little more complicated in the debugging process. So promoting it to being something in the object, it doesn't really add anything logically to the problem. It just makes life a little bit easier for you later. So that's one of the fun sorts of sides of C and C++ mixing there, and having like a private function versus the same sort of thing in a C file. You'll notice also that C++ is much more verbose, but in that verbosity, it adds clarity. So you can't really tell too much from what's going on here, and you can't tell if my function is related to send data. As we can sort of tell from this class, everything is related, and that sort of thing. The other thing that is really nice, and I'll go through and I'll add comments at the end just like I've done the past couple of days because we're starting to come up on the top of the hour, is you can add in Doxygen comments and that sort of thing. And if you follow it as a C++ class, you can sort of logically group things. As where if you do it just as C, you're sort of reliant on your file structure to logically group things. Now, there are reasons why you might want to use C over C++. If you're targeting something embedded, like a microcontroller, think about like an Arduino, or something like that, that maybe doesn't have a compiler that supports C++. That's one reason why you might want to use C. And you can actually make C look and act a lot like C++. You can create structs in both C and C++. And I'll create one here in a second. We'll sort of end on that. A struct is basically like a class just with only data in it. But you can make it so that they operate on them and they require them. And you can make a list of every instance, so to speak, of your object in C. So yeah, you can do stuff like that. So let me talk to you about structs. We'll do it on the C side here, and then we'll do it in the C++ side. There's a whole world of type defs and stuff like that. Structs are one way to logically group data. So I'm a big fan of using structs when appropriate. So struct, uh-oh. It says you guys might be seeing some buffering now. I wonder if someone else is using some of my network. Hopefully this comes up and it's not too choppy. We'll go from there. Yeah, we'll see what happens. Let me see if I can do anything about that. Or maybe my network is just going caliwampus right now. We'll see if we can get that back up. We're now yellow. Oh, now we went red. We'll see if we can get that back up. I'm going to keep going, though, and hope that this gets up there. But a struct, in terms of concept, is basically a logical grouping. Is a logical grouping of data. So this, I'll call it struct ASDF under my clever name. And maybe in here I include an int, A, or int X, and an int Y. Maybe it's position. Give it probably a better name. And maybe in here, in my C file, I will say position car. Nope. Hopefully the stream is back. It's saying now excellent condition, so hopefully that's good. Is it back? It seems to be back, hopefully. I don't see any comments saying otherwise, but so here I'll use this struct position car, And then I can say car.x equals 5. Car.y equals 10 or 19, that's fine. And then I'll say a plus equals car.x. Right, and then this minus equals car.y. So I've logically grouped this data inside car, and I can use it and sort of reference it kind of like an object. It's generally poor form to have really anything more than data in there. You can have operators on it, like structs in both C and C++, although a struct is superseded by a class in C++. So if you have a class of just, variables, that is essentially the same thing as a struct. And I recommend using the class more in C++ because as your code evolves and your project moves forward, you might decide that you need to promote it to have more useful values. But we'll build it here just to show that it works. There you go. It changes values that we can't see. But that gets us up and running there in showing you how to use a struct to do that. You can also make arrays of structs. You can make all sorts of stuff like that. You can use them in calculating the size of things. There's a lot of opportunity there to sort of play with it and grow. So it's a nice way in C to sort of have some of the luxuries of C++. Well, I'm a bit over today. I apologize for that. Covered a lot of the differences and how to use C and C++ together. A little intro on object-oriented programming, in case you needed that as well. Had some good questions there in the comments. We saw some structs, we saw some classes, we saw some functions. We compared the functionality between the two and sort of saw some examples of that. So a lot of good content. Hopefully you find this helpful, and we'll go from there. But if you have any other questions, like I said, I'm just going to flip this over, comment all the code so you have this. Probably not comment the main function since it's printing a lot of comments, but go through and sort of save all this in a good state and then push it up to GitHub for anyone who wants to view it later. Or check it out later. So anyway, thanks for joining me. I'll be back again tomorrow at 1 o'clock, and we'll see how this goes. We'll continue to talk about networking. So that will actually be very interesting, sending packets to and from different computers. And then we'll talk finally on Friday. Switching it over and just doing some commenting here, and then I'll end the stream as soon as my comments are done. And if you have any other questions or anything, feel free to jump on. And if these comments help you, feel free to watch. just thought I'd point this out in case there's anyone still watching the stream here. I forgot to delete the value here at the end. It's good form to do it, not required because it's going to go out of scope and probably won't matter, but it's good form at the very least to do that. So just thought I'd add that in here if you're still watching. We'll get back to commenting.